Welcome to this tutorial on how to solve a quadratic inequality. What I've done is write down a typical quadratic inequality that you can expect to solve. In this case, it's x squared minus 3x minus 4 is greater than 0. Okay, to solve this, let's just write down the inequality again. So we've got x squared minus 3x minus 4 is greater than 0. And what we would normally expect to do is to have an expression here that would factorize. So we factorize it in the usual way. So it'll be a couple of brackets, greater than 0. Don't forget the greater than 0. At the beginning, we'll have an x times an x. That will give us our x squared. And look for two numbers now that multiply together to give negative 4 and also add together to give minus 3. That will be plus 1 and minus 4, so we'll put plus 1 in here and minus 4 in here. So we have x squared minus 4x plus 1x, that's the negative 3x, and then 1 times minus 4, negative 4. Okay, where do we go from here? Well, all too often you see students making a very common mistake, and I'm just going to say what that mistake is, and you might already know it. I just want to reiterate it though. That is to say that x plus 1, the first bracket here, is greater than 0, or the second bracket, x minus 4, is greater than 0. Don't ever do this. This is totally wrong. Okay, if you did do this, let's see what the answers would be. We would subtract 1 from both sides here to leave us with, therefore, x would be greater than negative 1, or in this case, adding 4 to both sides, x would be greater than 4. This is totally wrong. So I'm going to put a cross through this. You'll see why later. Okay, so don't make that mistake. Okay, so what do we have to do? So going back to our factorized quadratic inequality here, we look for something called critical values. So I'm going to write down here for the critical values, and I'll explain what they are. For the critical values, just write that quickly, critical values. Critical values are where the left-hand side, x plus 1 times x minus 4, equals 0. So I would say that x plus 1 would equal 0, or x minus 4 would equal 0. And in the usual way, subtracting 1 from both sides would therefore give me that x is equal to negative 1, or adding 4 to both sides here would give me x equals 4. Okay? Right, what we now do is draw a graph. Draw a graph of y equals x squared minus 3x minus 4, which really is exactly the same as me drawing the graph of y equals x plus 1 multiplied by x minus 4. And the critical values will help me sketch the graph. So first of all, we'll just go over here, draw our y-axis. So the y-axis in, draw an x-axis, mark in the axis, don't forget that, arrows on both ends. Critical values, this is where the graph of y equals, the one that we're trying to do is x plus 1, x minus 4. So I'll just write that in here, x plus 1, x minus 4. Okay, what was I saying about the critical values? Yes, that's where the graph will cross the x-axis, so we'll mark in negative 1 and 4. It isn't a graph that has to be drawn to scale, it's just to give us an idea of solving this quadratic inequality. Now we need to draw the graph in, and this is a positive x squared graph, x times x being plus x squared, and positive x squared graphs are U-shaped by nature, and it's going to cross the x-axis here at -1 and 4, so we would have a parabola, a U-shape graph, coming through here, like so, and up like this. Okay? Right, now, we're looking for values where this expression here, x plus 1, x minus 4, is greater than 0. And that happens on the graph where y is greater than 0. So I'll mark in where y is greater than 0. That's what we're looking for. And y is greater than 0 on this part of the curve and on this part of the curve. It's where the curve is above the x-axis. So here and here. And the values of x that we need to plug into this equation to make it greater than 0 must therefore extend from 4 outwards, so I'll mark it in green that way, and for values of x less than -1 out in that direction. That's where y on the graph is above the x-axis, where y on the graph is greater than 0. Okay, so what I would say over here is just sum up by saying from the graph, we can get the solution to our quadratic inequality. Clearly, x has to be less than -1, so we write that as x is less than -1. And we have this solution here, or, it's not an and statement, just an or statement, or x is greater than 4. X is greater than 4. Okay, and just, by the way, just looking up here, outlining the common mistake that I was telling you about earlier. Notice how we get x is greater than -1. Clearly it's not. X is less than -1. X is greater than 4. Okay, that worked, but as I said before, never go down this avenue. Always go for finding the critical values, sketching the graph, and from the graph read out the required